Welcome to Completing the Squares Part 2. In this case, we're going to go through the even questions because, again, I know completing the square is not necessarily the most obvious way to solve a quadratic equation, but I do want you to be aware of what it looks like and how to use it, okay? So I'm going to go ahead and slide on in and zoom on into problem number 2 here. It's in standard form. Awesome. I am going to make it be out of standard form. I'm going to take that first term, x squared minus 12x, leave those two together, and separate out the constant. So that negative 4 is going to move to the other side, or 4 is going to move and become negative 4 on the other side. Completing the square. Take your middle term, all right, your middle b value here, divide it by 2, and then square it. What you get is going to be added, and here's one thing to be aware of when you're doing these. No matter what this value is inside of here, whether it's positive or negative, when you square it, it will always be positive, okay? So negative 12 chopped in half is negative 6. Negative 6 squared is positive 36. What you do to one side, you need to do to the other, okay? Keep the balance of the equation accurate. On the left side, x squared minus 12x plus 36. Because we have accurately completed the square, we can factor that into x minus 6 squared. And on the right side, we've got 32. This is all nice. This is all happy. We're going to go ahead and take the square root of both sides. Okay. So x minus 6 is equal to plus or minus. Now, square root of 32. 32 is not a perfect square, but living inside of 32 is a perfect square. And that perfect square, the largest perfect square, is the square root of 16. And 16 is in there 2 times. So root 32 is really 4 root 2. So if you can reduce your roots, you should. Okay, so it's going to be 4 root 2. And then to completely isolate x, I'm going to go ahead and add 6 to both sides. So 6 plus or minus, let me get that, 4 root 2. Please don't fall into the trap of thinking that, oh, I can take 6 plus 4 and 6 minus 4. Keep in mind that order of operations here, this is 4 times root 2. So you'd have to do your multiplication before you could do either addition or subtraction. So just leave this as it is. It's happy, it's content, and I'm okay with that answer, okay? In fact, it's the exact answer mathematically. All right, so that's number 2. Let's go ahead and slide on down to number 4 here. Number 4, it's in standard form. Again, I'm going to go ahead and take that constant of negative 3 and move it. So x squared minus 10x is equal to 3. And what I want to think about is taking that b value, chopping it in half, and then squaring it to complete the square. So negative 10 chopped in half is negative 5. Negative 5 squared would be positive 25. What you do on the left, make sure you mirror it on the right side. Okay, that keeps the balance of the equation going. So x minus 5 squared is equal to, what is that, 28? Yeah, 28. Square root both sides. So x minus 5 is equal to plus or minus. Again, I want to look and see if there is a perfect square living inside of 28. There is. Off to the side if you want to write this out. It's the square root of 28 would be root 4 times root 7. So this is really 2 root 7. All right, so 2 root 7. That's a horrible looking 7. Let's try this again. 7, slightly better. So I want to get x completely isolated. I'm going to add 5 to both sides. So 5 plus or minus 2 root 7. And again, you can't add the 5 and the 2 or even subtract the 5 and the 2 because the 2 is attached to that root 7. So we're going to leave that as is. Okay? So that's problem number 2, problem number 4. And let's take a look then at problem number 6. Unfortunately, number 6 is its own little ball of treasure fun. All right? So there's 2 options for doing this. And it really depends on what makes sense in your brain. I'm going to actually show you both. So I'm going to split this right down the middle so I can do option, one method over here, and then we can do another method over here. First method I'm going to start the same way I've been starting, which is to get the x terms on one side and the not x terms on the other side. All right, so 9x squared minus 18x is equal to 7. Now, unfortunately, because we have an a value here that is not 1, we need to pay attention to this, because I can't just chop this part in half and square it, because that won't take into account the fact that there is a 9 here. So what you're going to do is actually factor out the 9 from just that left side. Okay. Still going to leave this space because I need to complete the square here. And so what I want to think about is now just dealing with this like we've been dealing with it. So I'm going to chop my b value in half. Negative 2 chopped in half is negative 1. I'm going to take negative 1. I'm going to square it. So what ends up happening is I am going to add 1 inside the parentheses. Now, you've added 1 inside the parentheses, but there is a multiplier of 9 outside the parentheses. So 9 times 1 means on this left side, I've actually added 9. So that's what I need to reflect on the right side. So it's going to be plus 9 here. Okay? So complete the square from here. That 9 isn't going to change. X squared minus 2x plus 1 would be x minus 1 squared equals 7 and 9 is 16. Okay? I want to now solve this problem. I've completed the square. All right, so if you need to take a deep breath and make sure you're okay solving that part or doing that part, great. But you're completing the square is now done. I'm going to go ahead and divide both sides by 9. So x minus 1 squared is equal to 16 over 9. Don't bother changing the fraction. Just leave it as is. And we're going to go ahead and do the same thing we've been doing for a lot of these problems. We're going to take the square root of both sides. All right. So on the left, you just have x minus 1. On the right, we've got plus or minus. Now, don't get weirded out about the square root with a fraction. You can literally just take the square root of the numerator divided by the square root of the denominator. So the square root of 16 over 9 is really just 4 over 3. Okay? So doing a whole bunch of work here, right? We're getting there, I promise. I'm going to isolate x by adding 1 to both sides. Okay, so x is equal to 1 plus or minus 4/3. Now at this point, I don't have any radicals left in this problem. There's no more square roots, so I'm actually going to solve this all the way. So I'm going to take 1 plus 4/3, get that answer. All right, leave it as a fraction, please and thank you. So 7 over 3. And I'm also going to take 1 minus 4/3 and write that down as my fractional answer as well, so negative 1/3. So after all that hard work, we have completed the square. We have solved for x. So how do we do it? We start off at the top by doing the same thing we've been doing, except this time we factored out that leading coefficient for x. And basically, I don't want to say ignored it because we didn't, but we didn't worry about it to complete the square part of it. Okay? Now, once we found our missing value to complete the square, we did have to pay attention to that 9 as a multiplier, and that's why I added 9 to the right side, even though it looks like I just added 1 to the left side. Remember, this 1 is being multiplied times 9. So from here, it's solving using square roots. Okay? So that's one method. And if you're looking at that going, not a big fan of that, let's see what else you got. I'm going to show you what else, okay? So the alternative way to do this, we're going to start with the same equation. And in fact, I'm going to start with the same kind of steps here. We've got 9x squared minus 18x is equal to 7, okay? Now, instead of factoring out the 9, I'm going to outright divide it. Just divide every single part of this problem by 9, all of it. So the left side turns into x squared minus 2x. I'm going to leave that space to complete the square. And on the right side, I'm just going to be okay with having 7/9. Okay? So completing the square, we're going to do the same thing we've been doing. So let's see, we've got half of negative 2. So that would be negative 1. Negative 1 squared is plus 1. what I do to the left, I'm going to come over here and do to the right. Okay. So on the left side, this is now complete. I can rewrite that as x minus 1 squared. On the right side, I'm going to take 7 over 9 plus 1, and I get 16 over 9. This should look familiar because this step is exactly what we had here as the last step in red. So the way to solve this from here down is identical, okay? And I'll talk you through it one more time just to make sure you're okay. We're going to go ahead and take the square root of both sides. Okay, so I've got x minus 1 here is equal to plus or minus, and you're going to take the square root of the numerator and the square root of the denominator just separately. So that's 4 over 3. To isolate x, we're going to add 1 to both sides, so 1 plus or minus 4/3. And then the last step again, we're going to do 1 plus 4/3, which is 7/3. And 1 minus 4/3 is negative 1/3. Now, obviously, we knew from the start our answers would match. It would be very bad if they didn't. So yeah, the answers have to match, but obviously the method really is up to you. All right, so if you are okay with this little fraction here that you just deal with, and don't worry about then having the 9 in front, and do you need to add 1 or add 9? It's really up to you. I do both methods depending on which day of the week it is, I think. But ultimately, make sure you understand how to deal with having an A value that's not 1. I hope this has helped with some completing the square problems.